Hello guys, today we are again going to be solving for variables in terms of another variable, but this time we are going to be working with linear equations and specifically throwing in some fractions in there. So we are going to treat this exactly the same. Start by drawing that line right down the middle of our equal sign. We are going to be solving for h, which is smack dab in the middle of our parentheses, so we got to get it out somehow. And I know that I'm going to be solving for it, so I'm just going to write it down below. Now, one thing I want us to remember is that anytime we are multiplying by a fraction of 1 over 2, or any fraction for that matter, remember a fraction is the same thing as division. A fraction is the same thing as division. I'm going to just write off to the side here. We need to remember that 1/2 times g plus h minus k is the same thing as g plus h minus k all over 2. This is the same exact thing. If you think about it, there is an invisible coefficient of 1 sitting out in front here, and if we did distribute that in, it would read exactly the same. But we're dividing everything here by 2, okay? Now I know in the last video I said that I normally would like to distribute this coefficient in to everything, but when I'm dealing with a fraction, I know that all of us really dislike fractions, and that's okay. So we need to remember that we can always multiply by what's called the reciprocal, okay? We're going to multiply by the reciprocal. And a reciprocal is the opposite of something, okay? The opposite. So we're multiplying both sides. I'm going to go ahead and erase this. You guys can keep this in your notes, but I'm going to erase it just for space sake. And I'm going to multiply both sides by the reciprocal. Now, what that means is we are literally flipping that fraction over on its head, and 1 over 2, the reciprocal, becomes 2 over 1. I'm going to write a quick note off to the side here that this is, oops, there we go. The reciprocal is the opposite. Okay? So with that, we are left with canceling out because 2 times 1 and 2 times 1 cancel, cancel. All we are left with on our right-hand side is going to be g plus h minus k is equal to, now, I'm just going to write it as 2f. We are multiplying that 2 by f, okay? Now the rest is all the same. I'm just going to be using opposite operations, and that's actually exactly what we did up here. A reciprocal is the opposite of something. But instead now we're going to be using those algebraic opposite operations to solve for h. We also are going to be adding a k to both sides. Draw that horizontal line. We got 2f plus k is equal to g plus h. I'm going to scooch that down a little. And then remember, we're solving for h, so I'm going to subtract that g because we know this is a positive because there's no negative. And I'm going to subtract g from both sides. Again, draw that line. These cancel out, so all I have left with on this side is just an h is equal to 2f plus k minus g. We have solved for h in terms of the other variables, but this time using a fraction. Okay, box that answer off, and let's do one more example. Oops. This time we are going to be solving for the capital G. Our equation is d is equal to 2 over 9 times f plus g, okay? So again, we are going to be multiplying by the reciprocal. It is an opposite operation. It's that opposite operation of multiplying by 9 over 2. anything I do to one side, I do to both sides. And now remember, 2 times 9 is 18. 9 times 2 is 18. We end up with 18 over 18, which is just one whole. These cancel out. On our right-hand side, we are left with just f plus g is equal to 9 over 2d. Now, some of you guys might be wondering why I ditched the parentheses. The reason I decided not to write the parentheses again is because I know that there is nothing else happening now outside of those parentheses. There's nothing that needs to be considered distributed. There's no other things that need to occur. It is only f plus g left over, okay? And now remember, we are solving for g, so we need to bring the other variable over to the opposite side by using the opposite operation. And remember, this here is a positive because there's no negative. So we need to subtract f from both sides. All we are left with on our right-hand side is g. And we are left with, on the left-hand side, 9 over 2d minus f. So again, we have solved for a variable in terms of the other variables, including using those opposite operations by multiplying by the reciprocal. Thank you guys. I hope you have a great evening. I'll talk to you later.